In our Data Masterclass podcast, data leaders share their unique stories. In this episode, we talked with Dr. Matthias Lein, Chief Technology Officer at Alexander Thamm, about the topic of multi-agent systems and how different AI applications can work together to solve complex problems. Let us welcome your host, Alex Borek.
Hello data leaders, welcome back after a great summer break. I hope you're enjoying the summer at the Data Masterclass podcast, your podcast for everything that's going on in the data and AI scene for data leaders. We're gonna cover a rising topic in AI today, the topic of multi-agent systems. So how can you combine different AI applications together, playing different roles, almost like in a human team, with different team players on that team to solve jointly problems, and seems to be a very promising approach to solve basically hard problems with less computational power and maybe with some slightly simpler applications. And I have a wonderful guest with us today, Matthias Lein, the Chief Technology Officer at Alexander Thamm, which is one of the largest and also the oldest AI consultancies on the German-speaking market. You've been founded over 10 years back. Welcome to the show, Matthias.
Yeah, thanks, Alex. It's great to be here again. You know, attending your masterclass back in Berlin was a lot of fun already. So I'm really looking forward to talk Gen.AI and multi-agent systems in particular with you. And you're quite right. RT has been in the market for more than 12 years now. And of course, back then, data and AI solutions were completely different, right? It's hard to believe that, all the techniques we used back then are now sometimes referred to as classical AI, right? So this is machine learning, and we actually produced a lot of value for our customers there. Of course, the field has moved on quite a lot, right? Everybody's talking about Gen.AI since ChatGPT hit the market now, 1.5 years ago, I suppose.
Yeah, and that was a big moment. And I remember last year when Alex Thamm, actually the founder of Alex Thamm, was speaking at our rooftop panel together with Professor Stefan Ultis about what's going on in Gen.AI. He was telling, what really changed is I don't need to tell my mother or my grandmother what I do. Everyone gets it now. Now, it feels like a roller coaster since that ChatGPT moment. What do you think? Can you bring us up today? Because there's so much going on. What has happened since then, since OpenAI brought ChatGPT up?
I suppose ChatGPT was the first time machine learning and AI solutions were really tangible for every people, right? I mean, we've been working with machine learning solutions and classical AI systems for a long time, but mostly, I would say, the general public didn't really understand, right? I mean, this was number crunching. It was basically impossible to tell apart an HPC solution and a machine learning solution. But ChatGPT, I mean, it talks back to you, right? And it was probably the first NLP, so that's natural language processing method that was really approachable, right? I mean, it answered in complete sentences that appeared to make sense. Of course, it helped that almost immediately there was a web interface and also a mobile application that you could install on your phone, right? I mean, even school children can now use it to do their homework.
Not only school children. So what has happened, since then? Because I mean, it feels like there's new AI applications coming up every week. I think all the vendors are doing something in AI. It's stunning, isn't it? Like the amount of investment that is going into that space.
Absolutely, of course. I mean, when OpenAI hit the market with ChatGPT, everybody was in absolute awe, right? So now you had a computer that you could talk to that actually made sense when it answered. But of course, just having a chatbot can't be the end of the story, right? So now we are rushing through basically the Gartner hype cycle, right? Where everybody's trying to figure out what is the best application. Right. A lot of people want to talk to their data. That was probably the first application, right? So you feed your own company data into an LLM, and then you can talk to the data, you can interrogate it, you can make sense of it. And for simple features like customer support, I mean, this is definitely a very good solution already, but there's much more to come.
So, there has been a time before ChatGPT almost and after. Like, what has changed for you as an AI, consulting company? Obviously, I guess you have much more requests on Gen.AI compared to before. Like before, it was a lot of classical models.
Absolutely. Before we were really implementing classical models, right? I mean, basically tailor-made solutions that solved one particular problem. And now everybody knows about Gen.AI and they want to use it for everything, right? Which is probably not always the best solution for the case at hand, but it does have its advantages as well, right? And probably the biggest advantage is that I don't need to explain to C-level executives what Gen.AI actually is. Basically, everybody knows now the might behind these models.
Well, behind AI in general, I would say. I mean, it's not, people want Gen.AI, but often what they mean is an AI application, I guess, and they are not sure if they really need Gen.AI.
That's right? I mean, it's always about the application. You never draw value just from using a model, right? The model by itself doesn't do much. It doesn't do everything anyway, right? So you need to come up with the definition of the problem that you want to solve, and then we can craft an application that actually does it for you. Right. And there are different models from different vendors, right? I mean, OpenAI is by no means the only purveyor of large language models. Pretty much all the big names in the field now have their own. Some of them are even open source and free to use. Some are very hefty because they're really, really large, like, for example, ChatGPT 4.0 at the moment, right? Some can only be accessed on the web through an API. Some can be deployed on-premise in your own hardware in a segregated network if you want to, right? So there is really a wide variety of models that you can use in all sorts of circumstances. But again, right, it is always the application that you craft around it that actually creates the value.
Yeah, and sometimes it's also unclear if it's really Gen.AI that is needed, in the core of that application.
Absolutely. I mean, we've built proof of concept applications, right, just to show that something can be used with a machine learning application. And we use Gen.AI to actually prove that it can be done, but always with the caveat towards the customer as well. Hey, if you want to go into production with this, we need to use a classical model, which will be, much more customized towards your actual problem, and it will be much cheaper to run. But in terms of, iteration times and getting fast results quickly, fail early, fail often. Using these kinds of models to build your applications is a real benefit.
Absolutely. And so one thing that I've noticed when I look back 1 year ago, when I had one podcast recorded on Gen.AI back then, together with the head of AI research at British Telecom's Detlef, where we explored what the state of Gen.AI is at that stage. It was very early on. And in particular, not only that there were a few models out there, but they were not enterprise ready. And right now, what we see is that all major cloud providers have invested not only in enterprise-ready AI models, but really applications around that to really build end-to-end applications. And there's really a big set of services out there right now.
Yeah, you're absolutely right. I mean, all the big hyperscalers in the market and the data clouds as well try to lock their customers into their own ecosystem, right? They've been very successful with that. And usually if you choose one of those providers, you don't switch services easily, right? And now since Gen.AI and large language models are the next big thing in particular, of course, that would be the opportunity to actually switch providers if there was an actual advantage to choose someone else's model, right? And of course, everybody is rushing their own implementations, their own ML ops and LLM ops platforms that should enable you to build applications just as easily as those classical machine learning solutions that they've already been offering for a couple of years.
Yeah, it seems like it's getting easier and easier, and to a point where you ask yourself, when is the right time to, for which kind of application to join the game, because we might need double the. It seems like for the same application you built 6 months ago, you might need half of the, resources if you build it now.
Or even fewer resources, right? I mean, we've built chatbots and talk to your data applications a year ago, where our customers actually put a lot of money into the game early on just to enable us. And some of these would now be able to be built within, basically drag and drop click solutions on some of these providers' platforms. But of course, the right time to get into the game is now. The only thing that you should concern before you actually get in the game and build a Gen.AI or an LLM a solution is, do you actually have a problem, right? I mean, rushing something out just for the sake of building something with an LLM is clearly not worth it. But if there is a problem where LLMs are the right tools, by all means, dip your toe in the water right now, get some experience, make sure that you understand the technology so you will be able to implement it and use it in the right way.
Right. And when you apply it to your own problems, there are two main methods right now used. One is the one of RAG, so retrieval augmented generation, and the other one is fine-tuning. Could you explain a bit, what is behind those two and which one you would recommend?
Yeah, sure. The one problem, if you can call it that even, that large language models have is that they have a lot of generalized world knowledge, right? I mean, they have been pre-trained with all the knowledge that you can find on the internet, right? All those conversations on Reddit, everything that you can Google, right? Some transcripts from videos and podcasts even, right? So they know everything that is publicly available on the internet. But you don't need public knowledge for your company, right? You need very specific enterprise knowledge, right? And this is, of course, not known to any of the large language models. So you need a way to bring that knowledge into the model, right? And of course, you can use prompting. That would be the easiest way, right? I mean, we've all done it with ChatGPT. It's like, imagine you're Jimi Hendrix and you're writing a new song, give me those guitar chords just like Jimmy would do it, right? Or write a rap song in Snoop Dogg's style. And then, of course, because the model knows that, it is actually able to churn out a solution that sounds exactly like Snoop Dogg would write a song. And of course, you can do the same thing in a company context. But those context windows, as they're called in LLMs, they have a finite length. So it's actually impossible to put all that knowledge that the model would need into the prompt, right? You could not type everything down. So you need different ways of doing that. And in the olden days, with classical machine learning solutions, we would use fine-tuning to do that, right? So we take a pre-trained model and then we retrain it, right? It's called fine-tuning because it's basically done, but we throw some company knowledge, some more data at it and fine-tune it into a solution where it actually knows all that secret confidential company data. The problem with that, though, is that it is very expensive to do, right? Those models that we usually use are huge, and fine-tuning them costs a lot of money, and it takes a lot of time and actually expertise as well. And of course, the second obstacle there is that not all of the LLMs actually support fine-tuning, right? I mean, OpenAI, for example, for ChatGPT 3.5, maybe even for the 4 version, does offer fine-tuning, but it's like an early access program that not everybody gets into. So you might actually physically not be able to use fine-tuning in those.
And you said it's quite expensive. Can you give us a number?
Yeah, well, you need GPUs for that, right? So those hardware accelerators, NVIDIA's are the most famous ones on the market. Those are a scarce resource. So we're already talking about the most expensive compute that is available in the cloud right now. I mean, these sometimes cost tens of thousands of euros or dollars. Doesn't matter in that case if you want to buy one for on-premise training. And then we're talking about sometimes hundreds of hours of using on those, right? So we're talking serious money there that not everybody will be able to afford.
So basically some of the retraining and fine-tuning would cost you millions. Is that right?
Absolutely. Especially if you have a large corpus of data, right? I mean, if you're an internationally operating enterprise, there is a vast trove of data that you would need to use for your fine-tuning. And that, of course, gets expensive very quickly.
Yeah, and I remember the numbers that you have been showing during our Data Masterclass Europe, how much it costs to train the new GPT. I think it was horrendous.
Absolutely, those are staggering numbers. Not everybody has deep pockets like that.
Right. Wow. So there's another way which became a bit more popular because it's much faster to achieve results and it's cheaper, and that is the RAG approach. Is that right?
That's right. So RAG stands for Retrieval Augmented Generation, right? And like the name hints at already, right? We augment our generative AI by retrieving the information that we're talking about. And the way it works is you predefine which kind of data you want to include in your application. You sort it, you order it, and then you basically build a database that has all the knowledge in it, right? So in technical terms, you take all those texts, you tokenize them like we've done for years in NLP, right? And then we put them into a vector database, right? And the nice thing about the vector database is that it can do similarity searches, right? So sometimes you might not use the exact correct word that was used in the document, but because we can do semantic similarity searches in that vector database, we know when a term that you have been using in your request is actually really, really close to what the document says. So we can identify those documents that are most pertinent to the use case, and then put those into the context window of the large language model. And this way, we basically get the best of both worlds. We can include all the company knowledge in the large language model, but we avoid the trap of having to fine-tune a model in a very expensive way.
So let's dissect that a bit, because there's a lot of stuff in there, what you just said. So, I mean, number one, a RAG basically takes your data and doesn't refine. You don't fine tune the AI model itself in a way, but it feeds into the model, you could say, and it adds the relevant data from your database. So it searches for the data that is most relevant for that request and feeds that to the model as input, basically. That is at the core.
Exactly.
And to make that search which part of the database is most relevant, workable, and you need a vector database, because that makes the data better searchable. Your text data, it's mostly about text data, isn't it, in vector databases?
Yes, with retrieval augmented generation, we talk about textual data, right?
Right.
So let me describe one of the most common use cases for RAG, just to make it a little bit more clear how it actually works. So let's say you are a manufacturing company and you've got whatever you're building, let's say it's cars, right? You've got different cars, different models that come out in different years. And let's say, someone in a workshop now wants to figure out how to actually change a spark plug in your internal combustion engine, and then they want to search, hey, this is model A, it's a 1989 model, how do I actually do that, right? So usually your LLM wouldn't know that, right? Because this is proprietary data that is locked away in the manufacturer's databases in some sort of manual. It's probably printed out on the shelf somewhere in that workshop, right? But we want to retrieve that information now digitally, right? So then this request, right, model A, it's in the year of the build, is then tokenized, and the database is looking for documents that actually contain that information, right? And maybe the request you've been using is not actually using the correct model name, because maybe this is an old timer that has a lovely nickname, right? And the technician was using the nickname, right? So you wouldn't actually be able to identify a document that has the nickname, because manufacturers don't do that, right? They use the correct model name in their manuals, right? But because we've got this semantic search, right, and it knows that those two things are actually the same, it is still able to identify the correct document, reference back to that document, and look up the information that you're looking for in the correct manual for you, and bring it into the context window of your large language model.
So basically into your prompt.
That's right. So
to
your own
translate that a
prompt
bit.
is augmented by the prompt of the document that we have identified before.
Yeah, so basically, if you think about it, you write a prompt to ChatGPT today. Imagine that you, as a human, would go into your Excel sheet, search for the right stuff to put into that prompt. So you give your sentence, and then you add the relevant data from your Excel sheet. Let's say the context of your customer and some other things, that are maybe used then to write a letter to the customer. That's
Absolutely.
maybe something that you can imagine.
And it doesn't even end there, right? Because we have identified the correct document that is the source of the information. We can reference that back to you when we output the response of the LLM, right? So we can say, this is the answer. And by the way, it came from this document, and it came from page 4, section 5 of that document. And, there's then usually like a one-click solution where you can bring up that manual on the correct page to verify that your model isn't hallucinating.
And is that something that you see is widely adopted by now as an approach? Do you see?
Yes, absolutely. I think the first productive RAG applications came around, at least in the companies that we've been working with, sort of in the third and fourth quarter last year. This is when everybody wanted to have one. And to be honest, right now it is pretty much an industry standard. I'm not saying that everybody who needs a RAG already has one, but I think most people who want one have already identified the need and are now looking for the money for the implementation.
So most people have racked at least once.
Yeah, I think so.
But the rack show is going on. And so one of the things that you are encountering is that you actually need to take care of operations and security actually after you created that first rack model. And that might be sometimes a bit challenging because it's quite a new world. I think it's getting a little bit easier with the different cloud service offerings. But what are still the challenges with regards to operations, security, and responsible running?
Yeah, quality assurance is, of course, always an issue, right? And I mean, something that we've told each other and our customers for decades now is that, it's always the data quality. Right. I mean, if you give me a large SharePoint with thousands of PDFs that have manuals, just like in my example before, I can, of course, index them all and put them into my vector database. But I need to make sure that they don't contradict each other. Right. So maybe there are different versions of a manual. Maybe there is outdated information there as well. And this is something that is not detectable by the AI. This is something that I need to build guardrails for to make sure that I'm showing, the up-to-date document and not just the first document that actually came up in my search. So data quality issues are a big concern also with RAG, but that should not come as a surprise, right? It's always about the data stupid. This is what we tell our customers, right? If you don't have good quality data, you won't be able to build machine learning and AI solutions.
Yeah, until you have a good enough AI to fix your data. That day is coming, I hope. So I guess there's quite a bit of challenges also in practice, and that is, as you said, mostly around data quality. Where do you think RAG models come to the limit? Maybe you can give some examples of some applications that work well and some pieces where you say, hey, this is getting to the limit of what a RAG can do at the moment.
Yeah, so I think at the moment we're building more and more complex RAG applications, right? So a simple RAG application would be just built in just the way that I described, right? You have a prompt, you've got your vector database, you query it, you look up the right kind of document in your vector database, you churn out an answer. This is not really the state of the art anymore, right? So we're actually moving from these kinds of simple RAG applications to complex or advanced RAG, where we have more than one call to the LLM, where we, for example, clean up the prompt that comes from the user. Or we have more than one database, right? Maybe we have a relational database that has additional information that we are able to use to augment the user prompt to make sure that you actually get good quality information back. We can also use an LLM to guardrail the response of the LLM, right? I mean, we can feed the response into an LLM and ask, hey, does this actually conform to company policies? Or, have we retrieved something that we shouldn't churn out to the end user, right? So here we actually go to sort of rather complex constellations where an LLM is used to check the output of another LLM, whereas the input for that LLM was also prepared by another LLM, right? So you can see how we get different components that all use Gen.AI to have checks and balances. And this kind of setup is relatively complex. I mean, that's why we use the term complex RAG for it. And of course, keeping all this in the balance and making sure that we've got proper ML operations, in that case, it's sometimes called LLM MOPS, right, is something that is actually quite new, right? Because the kind of usual worries that we have with machine learning, like model drift, for example, right? Or there is a drift maybe in the kind of inputs that we're getting, right? Or we get new documents. This is all uncharted territory where we have best practices from our usual ML ops experience, but applying these best practices to that new situation is still a challenge.
And what are the use cases in different industries where you see some of these more complex RAGs working well? I mean, just some general examples.
Yeah, of course, I can't go into detail, right? But we've built the usual chat to your data kind of applications. We've built RAG applications that basically produce marketing copy that helps marketing. We have been supporting in the sales process. We have these kinds of applications that help with documentation in manufacturing processes in highly regulated industries that are not only regulated by European institutions, but also US institutions, where you have a lot of demands on the right kind of documentation at the right time, where you actually need to have a lot of checks to make sure that you don't have to throw away a whole batch of product, for example.
Okay, so very diverse scenarios where it can actually work.
Absolutely. I don't think there is an industry that would not benefit from this kind of solution in one way or another. Whenever there is text involved, and usually when people collaborate and cooperate, there is text and conversation involved. I think LLMs could play a big part in automation of that.
So whenever there are humans involved, you're saying?
Absolutely.
Very good. So you mentioned complex RAGs. Now, one thing that I started to think, I was starting to think when you were describing it, one LLM prompt checking the other output of an LLM, that sounds already a little bit like a multi-agent system.
Absolutely.
So where do you think the barrier is? When do we start to get into a multi-agent system kind of thing? And what is different with multi-agent systems compared to RAG?
So now we're sort of harking back into the old days of machine learning, right? If you read machine learning and artificial intelligence papers from 10, 20 or 30 years ago, everybody was talking about agents, right? Because we want to have systems that can operate autonomously, right? They can do their own stuff. And this is basically an agent. And now we kind of have, for the first time, built systems with LLMs that sort of do this, right? So we have one agent that prepares the input, then we have that second agent that retrieves and augments the output, and then we have a third agent that actually does the checks and balances and sort of does the safety considerations. That would be three agents interacting together. That is basically one of the simplest examples of a multi-agent system.
And so why do you need them? What's the advantage compared to? I mean, it sounds very complex at some point, So why do you add this complexity?
Yeah, absolutely. Well, it is complex, but it doesn't have to be complicated, right? In the olden days, when we were developing applications, we had to write code, different functions, basically for every piece of the solution that we wanted to implement for a customer. Right. Now we actually have a single piece of software, which is the LLM, that we can reuse in different capacities again and again. And this, of course, opens the possibilities for lay people to put together solutions that they couldn't before because they're just simply not coders, right? I mean, a lot of people can formulate their requirements. They can say, I want you to do this and that, and I want you to do the other thing, right? But they wouldn't be able to sit down and write Python code to actually implement that. But now we have a tool that could, well, in principle, even produce the Python code that fulfills this kind of function. So we have, instead of, lots of programming efforts to come up with lots of different functions, we have this one tool that can basically do it all. And this, of course, opens up a lot of opportunities.
And you basically use it to create different kind of AI, small AI applications. You could almost call them microservices.
Exactly.
For AI.
I think that's a very good comparison. I think those are analog to microservices. And of course, it's important to follow that idea through, right? I mean, the idea of the microservice architecture is that you have a tool that does one thing and this one thing very well. Right? And multi-agent systems, at least when we're talking about them in terms of LLMs, are very, very similar and very comparable in that sense. Because, I mean, imagine it, we could try to put all this functionality into one prompt, right? You tell the LLM model, hey, I want you to use my input and reformulate it and then retrieve that information. And then, of course, in your output, please consider, that you're not violating a company policy. And to a certain extent, right, with really good, powerful LLMs, that could work, right? But the longer your prompt becomes, the less likely the model is to actually stick to that prompt, right? I mean, it's very human in a sense in that way, right? We we know from experience when we have very long prompts that the LLM will usually follow the instructions at the start of the prompt and at the end, and the middle almost gets forgotten. This is actually really, it's not unlike how humans work, right? So instead of building more and more complex prompts, we actually work with very simple prompts and cut the whole solution into individual pieces that even smaller LLMs can do very well. And of course, there's the next advantage, right? We don't need to use the latest, greatest model. We can use cheaper ones, maybe ones that are able to be deployed on IoT devices because they're so small and the task that they fulfill is so simple.
You know what? I think that the inventor of multi-agent system was actually Henry Ford. When he started to create, different specialization within a factory where everyone specialized on a simple task and has been doing that over and over again until perfection. And isn't that simply bringing industrialization towards AI?
Absolutely. I think you're on the right path there, right? I mean, we keep it simple and can gain a lot of productivity out of that.
So every little piece, every single application can be quite simple, but put together, it's an enormous complexity that you can build out of it through many, many simple
Exactly. And
forms.
I mean, now the first providers are building these kind of multi-agent platforms. And internally at RT, we are developing our own, where basically everybody can build a little agent that you then add to a library. And then you've got sort of like a little marketplace of all these agents that have been pre-built. And then if you're looking for a solution to a new problem or an unsolved problem at least, right? You can have a look at what are the agents that other people have already thought of, and maybe I can combine them in a new and innovative way to solve a completely new problem. And that, of course, is very powerful, right? I mean, the App Store on your phone, right? There's also little applications that do different things, and I think this sort of agent marketplace could work very, very similar.
Well, and I also know Fiverr, which is a freelance platform. And it sounds like it's, a freelance platform for AI agent, for AI workers that can do jobs for you.
That's right. And they don't even work time-based, right? This is more of a token-based salary.
Well, you don't know. Probably we will see different things coming. Well, but this is exciting. But let's bring it back to reality. So basically, multi-agent systems is you combining different small AI applications. Let's say you have somebody writing, an AI agent writing a text, another an AI agent basically reviewing that text, maybe searching your database to see if that matches any keywords that, strike an alarm and need to be reviewed by a human, for example. That would be a simple, probably, combination of two AI systems. And I guess the specialty here is that you can actually program each component differently to fulfill a different role. You can have a small rack behind that. So let's say one agent looks up all your knowledge inside your knowledge database. The other one maybe looks into the compliance database, and everyone specializes also with that knowledge. Is that right? That's one way of combining these things.
There is definitely one way of combining those, right? I mean, you can almost build conversational AI with this, right? I mean, I've seen demonstrations internally here at RT from some of our experts who have basically built different agents that discuss a problem, right? I mean, ChatGPT is a conversational model, right? And you can have one expert in compliance, one expert in some other field, and you can ask them to discuss, and then there is a third agent that is the judge between them, and then they will present to the human a summary of the discussion. These are the pros, these are the cons. We think this is the best solution, and then you get to make the last call.
This is amazing. It sounds like this is getting very human, or like it's almost like watching a TV show. You can have people debating basically.
Absolutely. And I think we've all done it, right? I mean, sometimes ChatGPT gives back an answer that is not quite right. And then you go back to it and tell it, hey, have you considered this or that? Yeah. And then it actually improves the answer, right? I mean, this is common knowledge when prompting your chatbots now. And of course, why not use one chatbot to prompt the other?
And so what how far are we here with these multi-agent approaches? Because I mean, there's been quite a bit of hype recently around that, and there are some big people in AI that believe that's the new frontier of getting the next leapage in terms of the next kind of level of AI applications. Is that something that you would say is still very experimental and researchy, or is that something that has practical implications already for companies?
Yeah, I mean, predictions about the future are always difficult, but I have the feeling that multi-agent systems are really picking up steam. I would say, particularly in the first half of 2024, I was feeling that trough of disillusionment on the Gartner hype cycle in terms of LLMs quite hard, right? A lot of customers wanted to build a RAG, and then, when they saw the actual performance, they first of all found out that their data quality wasn't good enough, and, that it didn't solve all of their problems. It solved the problem that it was built for, but it didn't improve the company's bottom line as much as they'd hoped for. And there was a distinct sense of disillusionment going on, right? But now we have the first productive multi-agent systems. Some of the big data clouds have now launched their own multi-agent platforms, so it's actually getting easier and easier to build those. And I think we're headed for a great future in terms of multi-agent systems. And one thing we haven't even mentioned yet is multimodality, right? So, bringing together images, videos, and text has been something that has been offered for quite some time. But imagine the possibilities of having those in multi-agent systems.
And so in your first trials, building something out in practice, what are the steps that you need to take to build a multi-agent system?
Yeah, I mean, as usual, the most important thing is to break down the requirements into easy steps, right? We said that we don't want to make those prompts too complicated. So we need to maybe draw a diagram, right? This is where the information comes in. This is where the data sources are that I want to use to actually work on the problem. Then try out, can it be done with an LLM, right? Prompt them, connect the outputs to each other, and then iterate over that, right? So the process of building a RAG, especially a complex RAG, and building a multi-agent system aren't that different. The question is really, do you have the platform to do that on, right? Because somehow you need to glue all these together, right? I mean, one ChatGPT does not naturally talk to another GPT like that. I mean, you can do it like in the demo of ChatGPT 4.0 and put two phones next to each other. That's of course not a productive solution, right? So either you use one of those platforms that are coming out now, or you need a specialty consultancy to do it for you.
Okay, so basically you have, so a key step is what Henry Ford was doing, looking at the manufacturing process and looking at the different steps, step by step, to take a complex problem and cut it into small pieces.
Exactly. You need to break down the problem into easily digestible chunks for the LLM.
Right. And then you need to think through, as Henry Ford would do, which kind of worker would be best for which kind of problem. Is that right?
That's right. Exactly. And then, of course, and as an added layer of complexity, sometimes those are called functions, right? This is when your model or your LLM actually reaches out to some other service, triggers an action or gets more information, right? I mean, we've seen LLMs that actually Google it for you and then sort of summarizes what they found on a search engine. And of course, you can use other functions like that, right? I mean, you can trigger a step in a manufacturing process. You can control IoT devices, right? If this is the sort of thing you're looking for, this, of course, needs to be implemented, but the sky's the limit there, and I've seen implementations of exactly those use cases.
Oh, amazing. That sounds really great. It sounds too amazing. What's the catch?
Well, there's actually a number, right? I mean, price is, of course, one, right? I mean, I've already hinted at the fact that with multi-agent systems, if you break down the task really nicely, you should be able to use smaller LLMs. Sometimes they're called small language models. They're still LLMs technically, but they're so small so they can run on an IoT device, for example, somewhere at the edge. But of course, this is not how people start, right? You always start with those big, powerful models, right? You go to OpenAI's API and you build your demonstrator that shows that it can actually be done. If you get stuck there, you will be paying big bucks to Microsoft and OpenAI, right? I mean, using those kinds of models in production is expensive. There's no two ways about it, right?
Right.
That's, of course, one thing. And then, of course, safety, responsibility, and reliability are always an issue. I mean, I don't think we're making baby steps in that, right? We've got a lot of experience in terms of explainable AI, in terms of guardrails, and making sure that your model doesn't hallucinate, right? That it doesn't make up stuff, so that the answers are actually grounded in reality. And, of course, also stick to policy, right? This is something that needs to be built. And like with all things, right? This is not everybody's first consideration when they get excited about a new idea, a new thing. But getting those into production is just as hard and arduous as bringing any piece of software into production. There's no free lunch there.
Well, I mean, it sounds to me that the amount of time that you need to spend to make sure that everything's going right is probably exponentially higher than with normal software.
So you think that building a solution takes a lot more time with a large language model?
No, I think it is making sure that the guardrails are in place and that application does what it's supposed to do is probably much harder. I think it probably depends on how much you can use the AI to run these checks for you. You know, how much is that part already of the application where you have several bots doing these guardrails for you. But I imagine if you have, to my experience, if you have one RAG, for example, one fine-tuned model, that is already quite hard to test because in its core, it's the LLM. The LLM is unpredictable.
That's right. I mean, there's a conversation to be had how deterministic systems like those are, right? And this is basically what we're trying to reintroduce, right? Because classical software, I mean, modulo those bugs that you always find in your software is very deterministic. And in the end, it will do exactly what you told it to do. And these are the kind of issues that we're still having with LLMs, that there might be edge cases that nobody has thought about.
Yeah, and now I imagine you have, one piece of AI software can do sometimes strange behaviors. Now you have a combination of AIs all doing something which they believe is the right thing to do, which they've been trained on, but it leads overall to some very strange behavior. And maybe you have another AI that catches it. That's kind of the happy path probably, and probably most of the time it would work, and maybe there's some other rules around that. But I think testing such an implication can, it can be quite a nightmare. Or let's say it can become a nightmare if you don't catch it.
Yeah, absolutely. I mean, testing those kinds of solution is a growing field in itself. And we're getting better at it all the time as well. I mean, software testing, QA, user acceptance testing, right? These are all techniques and approaches that are undergoing big changes now as well, because of course everybody is benefiting from AI-enabled software development. So these kinds of fields will need to catch up there as well.
What are the first attempts in testing such models? What do we need to do to test LLM models, multi-agent systems? Maybe that's new, but are there any first good practices?
Yeah, I mean, believe it or not, but it's not so different from software testing, right? I mean, in software testing, you build unit tests, basically telling you, with that input, I always expect that output. And you should always have this kind of golden prompt where you expect a certain response. Of course, not word for word the correct response, because, whenever there's an updated version of your LLM, it might formulate the response in a slightly different way. But you need to make sure that for certain queries, you get the correct response. Right, and the path ahead, right? The iterative way of improving your software always includes regression tests, for example, in traditional software development. So whenever you identify an edge case in your LLM-based multi-agent system, you need to write that down as a test for future versions as well, right? Just to make sure that funny prompting can't bring your whole system down.
And so, do you need somebody who's actually acting as the boss in these AI systems? Because usually, in Henry Ford's model, you have somebody overseeing people. And obviously in modern work theory, there are teams also that work without bosses, but still most organizations have them. Because you do have different agents with different intentions and motivations now.
Yeah, that's right. I mean, I like the idea of having a boss agent as well in my multi-agent system. But I think for those solutions that we have built so far, it's more like a self-organizing team where you do have somebody who's doing the quality assurance before it goes out to the end user. But I haven't seen a system that actually has a boss who's sort of in charge of all the other agents.
Okay, yeah, that will be interesting to see, but it might prove also those people right who believe, and you know, there has been some good progress in that kind of work without much hierarchies. And I mean, there's some evidence that can actually lead to better results. So maybe we can test that out with AI as well. Great. So I think the question that I would ask myself is, where's this thing going?
Yeah, like I said, this is the $1 million question, right? I think we will see 1,000 blossoms bloom in the multi-agent world. Like I said, the first sort of out-of-the-box solution are coming on the market now, and collectively we will gather experience on how to best develop solutions with that. I actually have very high expectations. Because as opposed to traditional software development, now everybody basically can build their own solution, because all you need is natural language, and you need to be able to explain to your agent what it should do exactly, right? I mean, this is not like those old low-code, no-code solutions where you push boxes on your screen and connect them. You can just tell the system what you want it to do, right? So the barrier to entry is even smaller. This means we get more eyes on the problem, more brains thinking about it, and I think in the end we can benefit from the collective wisdom of everybody in the company who's been maybe monitoring or executing a process for many years, who has all the detailed knowledge about this, and now they're able to formulate a solution that is doing exactly what they need.
All right, so that's the future. Now, if you are a data and AI leader today, what would be the first steps? What would be the practical advice you would give to them?
It's been the same advice for years now. Don't wait, don't wait for all your competitors to get started in this area. Dip your toes in the ice cold water and get started now. Right. Like I said, don't do it without an aim. Try to find a list of problems that you're having in your company or your enterprise, and then see what you can do with these kinds of technologies. I mean, we've been talking about lots of different use cases in this podcast alone, right? You can look around on the web. There are many more ideas. I think there should be an opportunity to actually get some experience with these kinds of solutions for almost everybody, and then just get it done. You need to gather this experience to actually make sure that you know all the opportunities and all the possibilities that you now have. Just waiting and seeing is not the right approach in this case, I think.
Wonderful. So that was a very, very exciting and insightful conversation that I had with Matthias Lein, the CTO of Thamm, an AI consultancy the oldest actually AI consultancy in the German-speaking region. And we talked about multi-agent systems, but also the current state of the art, which everyone is applying, the RAG models, and how you can combine them to very powerful multi-agent systems. Thank you so much for being with us, Matthias, and looking forward to have you at our next one of our next events.
Excellent. It's been an absolute pleasure, Alex. Anytime again.
Boric Data Masterclass, where great data journeys begin.